Assalamu alaikum everyone. Welcome to this introductory lecture on computer programming. So, in this session, we will explore the fundamentals of programming and the essential components of computer system. And like humans, we interact through different modes like language. And if we go to the technical side, we have mobile phones and other communication systems. So in this session we will cover how we can translate human instructions into a language that a computer can understand. So uh, the human instructions are basically given in the form of programs that include different languages like C++ is a programming language in which we give a specific instruction, or the specific instruction is given by the user to the computer to perform a specific task. So in the introduction, we would understand what is a computer. So computer is not just a metallic box, it includes software and hardware. So without software, a computer is just a metallic box. Software developed using programming languages, and one such power language is C++, programming language. So we can say that C++ is basically uh, is basically a tool to communicate between the user and the computer. Before diving into computer programming, we must understand some essential concepts, starting with the what a computer is basically. So computer is basically, if we understand the crux of the definition, we can say that computer is an electronics device that can do specific tasks through its processing unit, which is basically called the central processing unit, CPU. And if we dive deep into it, we have hardware devices like mouse, keyboard, and printer, etc. And we have softwares that can make the transfer of instruction between a computer and a user. So a computer is an electronic device that processes data and performs tasks based on the given instructions, and the instructions specifically are given by the users. So computers are different categories, like we have mainframe computers. Mainframe computers basically used in large organizations because there is a transfer of a bulk data. So if there is a transfer of bulk data, so there will be a processing of bulk data as well. So mainframe computers are used in large organizations. And the other one is mid-sized computers. So we can have mid-sized computer in our university labs. We have mid-sized computers, and in other business firms and other institutions that do not have a large data to process, so mid-sized computers are used there as well. And then we have microcomputers, we have our PCs and laptops that are basically used for personal computing, and to do daily tasks we use microcomputers. So these are the some of the categories of computers. So in this slide, a computer system is a combination of hardware and software that work together to perform tasks. So computer is basically designed uh, for doing tasks. It takes input and gives the output according to the user instructions. So computer system is hardware is a combination of hardware and software. Without uh, having both, we cannot design, or we cannot say that it is a computer system. and with both the combination of software and hardware we can perform tasks. Otherwise it's just a metallic box. So a computer consists of both hardware and software working together. The key components include CPU, main memory, secondary storages, or input and output devices like we have mouse and keyboard, uh, and the other one is our main memory like RAM and ROM. So these are some of the elements of the computer system. So now we will understand what elements, specific element that we mentioned in previous slides. So what each element would do for a computer. So first of all we have a control unit, that basically we can say that is a brain of the computer. Like it fetches and decodes instruction, like it fetches information from the user, that we can say it is an input from the user, and then decodes instructions in the form of programming languages. Like computer understand only two that are binary 0 and 1. So the control unit would do that, it decodes the instructions, and the computer processing unit would understand what uh, to do in different circumstances according to the input. So we have a control flow of information in and out of main memory, and controls operations of internal CPU components. So the other element, that is a program counter. So program counter basically point to next instruction to be executed. So in program we have a different step to step instructions. So what the program counter will do, it would point out the instructions to be executed that are given by the user. And the other element is instruction register, that holds instructions and controls basically the instructions that are currently being executed. So the other one is arithmetic logic unit. Basically it is designed to perform calculations and logical operations in the computer, and this is the flowchart diagram, or we can say a basic structure of how a CPU in what elements are included in the CPU. So these are basically control unit and instruction register, program counter, and arithmetic logic unit. So basically this is the structure of the CPU, what it looks like. So we have discussed in our previous slide what each of these elements would do. The others are primary memory. So in our computer we have different memory storages like RAM and ROM. Primary units are primary memory units basically includes RAM and ROM, random access memory and random read-only memory. So random access memory is volatile and loses data when power is off. So we can say that RAM is volatile. ROM is we can say it is a non-volatile and store permanent instructions that are given by the user, or that the instructions that are used in the computer processing unit. So others are secondary memory units that provides long-term storage to the computer and includes hard drives and other examples of secondary memory like hard disk, flash drives, floppy disk, zip stick, and CD-ROMs, tapes, DVD, and USBs. So basically these are some secondary memory devices in which we can store the data for the long-term usage. So now we will discuss input and output devices. Input devices are used to transmit the data between the user and a computer, or we can say a system. So input devices include keyboard, mouse, scanner, and secondary storage devices. Output devices where the result is displayed, or we can say that the required output according to the specific input. So these are the output devices: monitor, printer, and speaker. Through monitor we can see the output, or we can see the set of instructions output that are given by the user, and we can see that if that specific uh, processing unit is doing the task right or wrong, or either it is giving me the results according to the input, or the results that are desired by the user. So some of the output devices include monitor, printer, or speaker. So previously we discussed hardware, and now we will discuss software. So what basically the software? So we can say that software is what makes a computer functional. It is categorized into some categories like system software, application software, and so basically we can say that software is a vital and modern technology. System software, what system software do manages a hardware. Basically we can say that software can be used to manage hardware, e.g. we have a different operating system like Windows and Linux, and other software includes application software. Application softwares are designed for some specific applications. So we can say that application software are used to perform specific tasks, we can say that for example MS Word is used to design for documentation, and we have like Photoshop for editorial purposes. So these are basically application software. So computer languages, as we know that human interact through languages, like in specific region there is a specific language in which the people communicate. So in computer understands only binary language, like there are only zeros and one. So computer communicate or understand the data according to these two zeros and ones. However, programming languages like C++ and Python, Java are used, or they can be used to help us write instructions in a computer readable form, to basically communicate a human to a computer. So binary digits, and the binary digits are of course 0 and 1, and binary codes sequence of binary code, we can say that it is a set of instruction that include a sequence. Basically it's a sequential language, C++. So we can say it is a sequence of zeros and 1. So these are some introduction to the computers. So these are some binary units like bytes, kilobytes, megabytes, gigabytes, terabytes, and petabytes. These are basically binary units that are used by the computer, that includes sequence. So introduction to C++, we can say that C++ we have older version of which is called C. We can say that C is with classes, and became widely used. C++ is a machine dependent, independent, but requires a compiler to convert human readable. So compiler is basically what it will do. It will compile the whole program and give us the desired output according to the input. So here is basically the evolution of programming languages. So In early 1990s, we have computer that were programmed in machine language. As the computer programming languages were evolved, we have now C++ that are machine independent languages. So that's why we need a compiler. So here is why the evolution of programming languages was introduced, or we can say that it was inducted in the computer programming. So like here is the function of to calculate the area of the triangle through a machine code. So and basically the formula of of the area of the rectangle is length into width. So the machine code is here it is that is how it is written through a machine code. And if we see in C++, it is a change little bit because of C++ is a machine independent language. So assembly languages we have like C++, C and Python, closer to human as compared to machine languages. So there was a need that a system of languages should be developed that can understand humans and computer as well. So assembly languages are here introduced. So programming is a structured approach starting with the program solving phase, where we define a step-by-step process that is called algorithm, and then we use a flowchart to visually represent the logic that is being processed by the computer. So assembler is a tool that converts assembly code into a machine code. So assembly language code for we have seen previously that how machine coding works in early computers. So when the languages were evolved, we have assembly language that the code of the same code that is written in assembly language is load is a library. So length and multiplies a function with width, that is basically, and to store the result we have a store function, and it is basically storing the area. So now we have high level languages. High level languages are C, C++, C Sharp and Java. So compiler are the tools that are used to compile the source code into object code. So some predefined functionalities are already included in C++ programming. So here introduction of C++ is C++ was developed by Bjarne Stronstrup in 1979 at Bell Labs. So it was initially called C with classes and became widely used in 1985. Peer to the world, C++ is a high level language. C++ is a machine independent and a compiler is needed to compile C++ program to convert the user instructions to a uh, programming that is completely understood by the computers as well. So algorithms and flowcharts. Programming is a structured approach starting with the problem solving phase where we define a step-by-step process that is called algorithm. So we can say that a step-by-step approach to a specific set of instruction is called algorithm. Then we visually represent a flowchart that is called logic. Now to represent logic, basically we use flowchart to a desired problem. So problem analysis is required for both the algorithms and flowchart. So we can say that programming tasks can be divided into two phases, and the phases are problem solving phase and implementation phase. In problem solving phase we basically understand that what the user wants the computer to do, like it produce an order sequence of steps like sequentially because it is a sequential language. So produce an ordered sequence of steps that describe solution of problems. So this sequence of steps basically is also known as algorithm. So we have another definition of an algorithm. So the other phase includes the implementation phase. So it implements the program in some programming languages. So to solve a problem using programming, we have three steps: develop a general algorithm using pseudocode, refine the algorithm until it goes to a programming language, and convert the step into a actual program code. So example of pseudocode algorithm, let us consider an example like determining whether a student passes or fails uh, in subject of four marks. So what would be the pseudocode of it? Like we have input 4 marks for 4 subject marks basically, and then calculate the average, and we have set an threshold that is basically a 50. If the average is above 50, the student will pass, and if it is below 50, the student will fail. So it will uh, print fail or pass according to the average. So by following these steps, we can implement this logic in any programming languages. So this is a detailed algorithm. Like step 1, we would include the subjects of the subject marks of the 4 subjects. Like we can say that we have marks of one subject as M1, marks of second subject M2, M3, and M4 likewise. So step 2 would be the grade calculation. Like we would add all these marks and divide it by 4. If if it is greater than the threshold that is set to 50, so this would print fail, else it would print pass. So the flowchart is a graph, basically a graphical way to represent an algorithm. It shows the sequence of operation using symbol like oval, parallelogram, rectangle, and diamond. Oval is basically used for start and end. Denotes the beginning or end of the program. So parallelogram is used to denote an input uh, and output. So rectangle is basically used for processing, and diamond is for decision making. So example of a flowchart is basically a grade calculator that is related to the previous examples, that is calculating the marks of 4 subjects. So these are the examples. Uh, these are some example of flowcharts. So begin read age. These are some examples that you can see yourself. So here is another example. Write an algorithm and draw a flowchart that will calculate the roots of a quadratic equation. So there is a quadratic equation given: ax square plus bx plus c is equals to 0. So what we can do is basically square root of b square minus 4ac and calculate the specific task. These are the tasks that are given to you for your better understanding. So this was the introduction to C++, and so basically we have covered the basics of computer and programming, the components of a computer system, and evaluation of evolution of programming languages, C++ basics and importance. So and other we have learned algorithms, pseudocode, and flowcharts. So these foundations will help us to progress in learning C++ programming. Thank you for watching, and I look forward to our next section. Thank you so much. Like and subscribe, please.